In this video, we're going to be talking about the algebra topics of inequalities. We're going to look at graphs of inequalities, and then we're also going to touch a little bit on circles. So when we're talking about inequalities, from a math perspective, is when two expressions are not equal, but yet we use the expressions of greater than, less than, greater than or equal to, or less than or equal to with these expressions. And hopefully you're familiar with the different symbols that we use for each of these items. So it's usually easier if you can start off by using a number line to visualize a solution. You may be asked to find the solution for x minus 3 is less than or equal to 6 and find the representation of that on a number line. Give that a try right now and see what you would do. So the first thing you do is we want to solve this inequality by having usually x on the left-hand side and any other values on the right-hand side. In this case, what we'd want to do is we'd want to add 3 to both sides, and we'd end up with x is less than or equal to 9. Then to graph that, we'll take our number line, we'll find that point 9, and we know that our solution for this is any values to the left of 9, because x is less than or equal to 9. So any values to the left. So this is what our number line would look like for this solution. There's a couple of things we want to remember about inequalities. Anytime you multiply or divide through by a negative, we're going to need to flip the inequality sign. So if we have a question like this that we need to solve, negative 2x is greater than 4. To solve for x, we're going to divide through by negative 2. And when we do that, we're going to flip the greater than sign to make that less than. And then also don't forget, we still need to take care of the negative. We need to keep the negative because it's 4 divided by a negative 2. When you graph an inequality and you have equal in that, greater than or equal to or less than or equal to, remember the circle is a closed circle on the number line. And also it's going to be an open circle if it's only greater than or less than, not the equal. And these are two of those examples. So when we're showing x is greater than 0, notice at the 0 on the number line, it is an open circle. And for x greater than or equal to 0, we have a closed circle at the 0 that includes the greater than or equal to. So now when we're talking about graphs of inequalities, we can graph an inequality on a coordinate plane, and we will see the shaded representation of that region that is represented by the inequality along with the boundary. So the boundary of an inequality that has a greater than and equal to or less than or equal to inequality is going to be a solid line, and we're going to have a dashed or a dotted line as the boundary when it's just greater than or less than. This is the process that we go about when we are graphing an inequality. We're going to first start off by graphing the boundary line, and we'll use either the solid line or the dashed line, depending on if it's greater than or less than or greater than equal to or less than or equal to. And then we choose a few test points to determine if we're talking about the shaded region above the line or below the line. So in this particular case, we have y greater than 2x minus 2. We're going to have our boundary line that is a dashed line because it's just the greater than. We graph that as a hashed line on our coordinate plane, the 2x minus 2, and then we pick some test points. What I always like to look for is where the 0, 0 point is. And that's because it's easiest to plug in 0, 0. So we'll plug in 0 for x and 0 for y, and we have the expression 0 is greater than a negative 2. If that's a true statement, which it is, then that point 0, 0 is part of the shaded region, and that's why we'll shade, in this case, the region above the line 2x minus 2. If it was not a true statement, we would have shaded the region below the line that didn't include the point 0, 0. So choosing a test point, plugging it in, that will help you if it's included there. That's our shaded region. As you work more and more with this, you'll get better to be able to almost just look at it and tell that y greater than 2x minus 2 means the shaded region is above the line, but always you can use test points to determine that. Now let's shift a little bit to circles. A circle is a curve that always has the same distance r from the center. So we have a center point and we have a distance r, which is our radius. And here's the standard equation of the circle. We have x minus h squared plus y minus k squared equals r squared. And so the h and the k in that equation represents the center, and r is our radius. So if you'll notice in the equation for the circle, we have x minus h squared plus the y minus k squared. So the minus signs in between the two terms for h and k, the minus is what we have. So we're always going to have, it's almost like you have to look at the negative of that. So if you had an hk, a center value of 3, 4, you would have x minus 3 squared plus y minus 4 squared. So you take the sign, y negative sign is the standard in the equation. And we always have the plus sign in the middle between the two. So in this example, we have the center given of 0, 0 and a radius of 2, and we need to write the standard equation for this circle. So we're going to apply the standard equation that we have, and in this case, hk, the center is 0, 0, and when we plug that in, we're able to simplify to x squared plus y squared equals our radius squared, which is 2 squared. That gives us 4. We'll talk a little bit more about circles in another video, but that gives us the standard equation and the general setup of a circle. Take a look at this ACT type example now. Pause the video and then come back and we'll work it together. The question says, given the graph of the equation y equals x squared plus 2 and y equals x plus 4, what real values of x satisfy the inequality x squared plus 2 is less than x plus 4? When we glance at our answer choices, we see that we are looking for an expression that represents an interval of values for x. That's what we're looking for. So we look at the graph that we're given, and most of the time if we're given a graph on the ACT, it should be there to help us. We can look at the equations, but we can also look at the graph and see if that can help us. And we're wanting to know where x squared plus 2, and that is the parabola that's in the light blue, where it is less than that line that's drawn in blue, the x plus 4. So when we look at that, we'll see this colored section that we have in is less than or below the line. It's the portion inside the parabola that is below the line. That's what we're looking for. So then what we have to do is we want to know what interval of the x values are included in that shaded region. And we can tell that that goes from -1 to 2. So when we're looking for that in interval notation, it turns out to be answer choice D. -1 is less than x is less than 2.